Thank you. This afternoon I'm going to speak about the Ice Age. Only the Bible can explain it. And by the way, people tell me that when I talk about this subject, a chill goes through the audience, so you better have a sweater. Anyway, only the Bible can explain it? Well, how does that pan out? Well, I'll let you know. Anyway, what is an ice age? Well, it's essentially a great increase in snow and ice. 10% of the continents are covered by ice today, mainly Antarctica and Greenland. During the Ice Age, it was 30% of the continents, mainly in the high latitudes and certain areas of the mid-latitudes, and in the mountains of a lot of places. Also, it's the last major event in Earth history, both from the secular science point of view and from the creation science point of view. I'm going to come back and revisit this theme at the end. Whoops. What's going on here? Actually, the secular scientists, this is their view, they have 5 major ice age periods in their Earth history. They have what's called the Pleistocene, the last 2.6 million years, the late Paleozoic, late Ordovician, late Precambrian, mid-Precambrian. And in the Pleistocene, they have what they now believe is 50 ice ages, but only their last ice age mostly corresponds to the post-flood rapid ice age, which I'm going to tell you about. The previous ice ages are seen on the hard rocks, and they see what they think are ice age features, and they claim, an ice age millions and millions of years ago. So I call those ancient ice ages, and I looked at that data long ago, and quite a while ago, and determined that there are gigantic submarine landslides during the flood. Some of the special features can be explained in the flood. And long ago I dealt with that in this book. It's kind of old, but it's still good. Anyway, ancient ice ages are gigantic submarine landslides. Okay, here's the challenge of the ice age. Secular scientists kind of think that get a little cooling and presto, the ice age begins. They also claim that there's many ice ages. They started with only one ice age when they discovered the ice age in the mid-1800s. And by the way, the ice age, when it was first discovered, was an assault on uniformitarianism. How was that? Well, they discovered that there was a lot of ice that was over northern United States, Canada, northern Europe, and there wasn't any ice there today. So it wasn't a present process. So the man that really developed uniformitarianism, Charles Lyell, never did accept the ice age because it defied uniformitarianism. But as time went on, they fitted into uniformitarianism, and they went from one ice age to 4 ice ages. For 60 years, all they saw when they went out in the field in glaciated areas was 4 ice ages. But that's all gone. There's no more 4 ice ages. There's now about 50 ice ages. Well, how do they get 50 ice ages? Well, it's based on sediments on the bottom of the ocean. They send these cores down there. It picks up all this mud and shells of organisms. They pull it up and they analyze it, and they see they analyze it for several variables. And the variables wiggle down the core like this. So they claim that when it wiggles this way, it's a glacial. This way, it's an interglacial. So that's how they get 50. So of the 50 ice ages, each ice age takes 100,000 years, and the glacial phase is 90,000, the interglacial 10,000. But when you get older than 1 million years, they oscillated not every 100,000 years, every 40,000 years, they claim, in regular succession. This is because they make a major assumption. They believe in what's called the astronomical theory of the Ice Age, which, or the Milankovitch mechanism, where the Earth's geometry changes a little bit if you extrapolate it backwards. So every 41,000 years, the tilt of the Earth oscillates just a little bit from 24.5 to 22.5 degrees. Just a little bit. They think little things like that and two others cause these major climate change called the Ice Age. Meteorologists have, this is an old theory, by the way, from the 1800s, and meteorologists have pointed out for many years that these effects, if they occurred in the past, are too small to cause an ice age. But that's all they got to go on right now, and they love oscillations because when it repeats at a regular sequence, it seems like it's uniformitarianism, uniform present process. So that's where we stand, and they challenge us on that. How can you explain the Ice Age from the Bible? And here's a quote from an atheist. Increasing the duration of the Ice Age by a factor of about 10 greatly increases the stress upon the creation scientist who must compress the events of 15 million years into 4,000 years of post-flood time. Now, this atheist actually did his homework. He read a lot of our material. We have a massive amount of technical data out there in our 3 technical journals that we publish, the Creation Research Society Quarterly, the Journal of Creation, and the Answers Research Journal. The Creation Research Society Quarterly is over 60 years old. We've been publishing it. So we got over 60 years of research, and he looked at a lot of it. He looked at a lot of our books. So he got a lot of things right. He wrote a big, thick book challenging us called Science and Earth History, the Evolution Creation Controversy. But as an atheist, he got about half of it wrong because of his worldview. But he got about half of it right, which is a lot better than a lot of theistic evolutionists when they challenge us. I've read their material, and a lot of times they don't hardly read our material. So, and you know this because you look at the references. This man did his material, and he challenges us. And what's this about increasing the duration of the Ice Age by 10 times? Well, the history behind that is because of other data from deep sea cores around Antarctica, they decided that the Antarctic ice sheet must be about 10 times as old as they thought. So that's the basis behind that. And he says when they do that, that stresses us even more. Oh, yeah? Well, let's see if we can meet the challenge. We're going to apply my theme verse for research. Examine everything carefully. Hold fast to that which is good. I'm holding fast to the Bible as God's Word, but I examine the data. I look at the observations. I throw out their interpretations. A big difference. Their data, we don't have any beef with their data that they bring up, their observations. It's their interpretations. That's where the major problem in creation, evolution, and in deep time, which is millions of years, that's where it's at. They're the interpretations of 2 worldviews, the biblical worldview and the atheistic worldview. Okay, I'm going to present this as a series of questions. First of all, was there really an ice age? Some Christians still don't believe in the Ice Age because they hear all these millions of years with it, and they says, well, that goes against the Bible. The Ice Age must be false. Well, we need to go examine areas that are glaciated and see what occurred. Like present-day glaciers today, we can see what they do. Here's a glacier coming out of the mountains, and when they spread out, they push debris to the side. And in the front, they form a ridge of debris called a terminal moraine or an end moraine. And they push it out towards the debris out to the side, and it becomes a lateral moraine. So you see these with especially valley glaciers. And a great place to look at glaciation is the beautiful Athabasca Glacier in the Canadian Rockies. And the ice was out there in 1890, and practically all the glaciers of the world have been receding since about 1890 due to global warming. My field is atmospheric science. I can tell you a lot about global warming. I'll make it short since I'm off in this tangent. Essentially, it's 10% reality and 90% politics and hype. But more specifically, the temperature's warmed about an average of about 2 degrees Fahrenheit. In the polar areas, a lot more. And we can show that half of that warming is due to natural processes of climate change. For instance, the medieval warm period between 800 and about 1200 AD, where all the glaciers of the world retreated, and the Vikings colonized southwest Greenland. Then we had the Little Ice Age between about 1330 and 1890, where all the glaciers in the world advanced. The Little Ice Age. And it's kind of funny, you read some of the reports in Switzerland, some glaciers advanced and came out into the town. And they tried to get some of the local priests out there to kind of jinx it or whatever they were trying to do, pray against it, but it kept coming and it destroyed parts of the town. So it's kind of an interesting scenario. But what do we see around the Athabasca Glacier? Well, we see rocks of various sizes all mixed up with a lot of fine particles around them. I'll call it a fine matrix. And in front there you see ground moraine, kind of hummocky, bits of debris. And then you see in the front a terminal moraine, and on the sides the lateral moraines. There's a better picture of the lateral moraine. It's very sharp looking. You can see some of the boulders in that moraine, but it's rocks of all sizes in a finer grain matrix. So that's typical of glaciated areas today. And when a glacier moves, it has debris in the bottom. And the debris scrapes along, as it moves, scrapes along the bottom. And the boulders get scratched, called striations. And a lot of times, because the ice is plastic, the boulder will move. And it'll scratch the boulder in different directions. But it'll always scratch the bedrock in the same direction. So this is a boulder from the Athabasca Glacier where you could see at least 3 sets of striations on it. And the bedrock shows the striations going from west to east in this case. So when we examine areas that were claimed to be glaciated during the Ice Age, what do we see? Do we see these features? Indeed we do. Now this is west of Augusta, Montana. You see the Rocky Mountain front there, and you see this mound of whatever. You can see some of the rocks sticking out. It's a mound of glacial debris with rocks of all sizes. And this is an end moraine that's been kind of rounded with time, and it actually was continuous to where I was standing over here, but for some reason it broke out here. Probably because it dammed up a lake, which is common for moraines to do, and it broke through. And that's where they built the reservoir for Augusta. I think it's Pishkin Reservoir. I hear it's good fishing too. And so you had ice out here in Augusta where temperatures get up to about in the mid-80s for highs in the summer. Too hot for glaciation today, or even in the northern Rockies, way too hot summers. And summers are key to melting ice. And when you look at the terminal moraine, you see rocks of all sizes in a finer grain matrix, exactly what you see at the Athabasca Glacier in the Columbia ice fields in Canada. And some of the rocks in that moraine are scratched in different directions, like this boulder right here. And when you go up on the Rocky Mountain front, where the ice occurred in the northern Rockies, south of Glacier Park, and it moves from west to east down an 800-foot cliff and about 15 miles out into the plains. That's all it made it, 15 miles out into the plains. You hike up there, and you hike up from the other end, which is just an easy hike up to the top, not the vertical face. You see scratched bedrock. And notice, it hasn't been weathered out yet. It's still there, indicating that the Ice Age occurred not that long ago. And I might add that these rocks here are flood rocks. So it's on top of flood rocks, giving you a hint that the Ice Age occurred after the flood, which I will get into. And you see a lot of other interesting glacial features. This is the top of the Sierra Mountains, where the ice moved, and it actually polished the granite. This is granite, and it left some erratic boulders as it melted. And here's a lateral and end moraine from the northeast Wallowa Mountains near Enterprise, Oregon, where the temperatures get up in the low 90s for highs. And so it'd be very, very difficult for ice to occur in the Wallowa Mountains, even in today's climate. By the way, when I say today's climate, because uniformitarians rely on present processes. Present processes of climate change, or extrapolated back for this astronomical theory. So that's all they got to go on. It's really very small changes that they rely on. But anyway, it's interesting. This glacier came out of this valley and it over-deepened this lake. Glaciers tend to over-deepen valleys. On the west coast of Norway and British Columbia, they're called fjords. And they're really picturesque if you ever take a cruise up in the Norwegian fjords, which I haven't done, but I like to someday. Anyway, when we take a look at these moraines, from the bottom, we look at this lateral moraine. Notice how sharp looking it is still. Look at the trees for scale. That lateral moraine is 600 feet tall, indicating you had probably 2,000 feet of ice that come out of that valley out towards Enterprise, Oregon. And when we look in the moraine, it's typical of glacial moraines today. Rocks of all sizes in a finer grained matrix. And this type of rock is granite, since the Wallowa Mountains are mostly granite. And you see these erratic boulders all over northern Montana, Canada. This is a special erratics called the Okotoks erratics, southwest of Calgary, Alberta, Canada. And notice how angular that huge boulder is. That didn't come down by ice. That had to be moved by an iceberg, because if you rolled it or the ice got to it, it would round off those sharp edges. And this represents a boulder train that starts from Jasper, Canada, down to Cutbank, Wyoming, about 600 kilometers long, very narrow. And I believe this was formed during a gap in the two ice sheets that occurred in North America. The Cordilleran ice sheet occurred over British Columbia and the Canadian Rockies and spread out on the east slopes a little bit. And by the way, that's the ice sheet that occurred in this area. This area was glaciated. The southern end of the Cordilleran ice sheet was in this area. That's why you don't have Lake Missoula flood features here. You do in the next valley to the south. And then you had the Laurentide ice sheet in central and southeast Canada, but between them you had an ice-free corridor that was open for a while that allowed animals to cross the Bering Land Bridge and spread down the east slopes through Alberta into Montana, south, clear to Central and South America. That's how they got here during the Ice Age. The woolly mammoth, the Columbian mammoths, saber-toothed tigers, so forth, ground sloths. Anyway, the Okotoks, I believe, were depositing icebergs in that ice-free corridor. And here's a famous erratic boulder called Bubble Rock. This is from Acadia National Park in Maine. Of course, I got there at the right time when the trees were turning. That was purposefully, by the way. And we have this famous erratic boulder southwest of Portland, Oregon, about 50 miles. It's this material is argillite, and it doesn't outcrop anywhere in the state of Oregon. It's actually a rock from Montana and Idaho that is from the Belt supergroup around here. In other words, it's a slightly metamorphic shale. And that's not going to roll down there. It has to be formed by an iceberg. How is that? It's found about 150 miles south of the furthest extent of the Cordilleran ice sheet that came surging down Puget Sound area and stopped at Olympia, Washington. That's the furthest south that the ice occurred. Well, the only way you can get this boulder down here is in a Lake Missoula flood. And if there's a Lake Missoula flood, there was an ice age. And here's kind of a quickie on the Lake Missoula flood, which will be my topic tomorrow evening, I guess. In the valleys of western Montana, you had a lake that was about 4 or 5 times the volume of Lake Erie, and it was blocked by a finger of the Cordilleran ice sheet into northern Idaho. And we know it was about 2,500 feet thick because the mountains to the west and east were unglaciated at the tops. So it was about 2,500 feet thick, and it blocked up this lake, the Clark Fork River, and the lake was 2,000 feet deep. And it broke through this suddenly in a matter of 2 days, filled up glacial Lake Columbia, and overspilled a ridge going southwest of that green area there. So that's the Lake Missoula flood. So if there's a Lake Missoula flood, there definitely was an ice age. And from space in eastern Washington, that's the path of the Lake Missoula flood, where it channels around and leaves chunks of the rock or the sediment on top, which is silt, uneroded. That's a path of a braided stream 100 miles wide. I'll talk more about the Lake Missoula flood tomorrow. And you see a lot of features, these lens-shaped hills on the surface by the hundreds in places. They're called drumlins. They're shaped by the ice, and they've discovered recently that they're shaped by surges, where the ice surges pretty fast. By pretty fast, it might be a mile in about 15 days or something like that. Not really too fast, but for a glacier, that's really fast. And it streamlines this material. And this next picture shows the southern Puget Sound area that is streamlined into drumlins. This is a LiDAR picture that gets rid of all that pesky biology. You see just the surface. I lived in this area. I'm from Seattle, and this really surprised me to see that this area was actually a bunch of drumlins. It's caused by surging of ice. I believe it built up in southern British Columbia, and there's probably a lake it blocked by blocking the Strait of Juan de Fuca. And then there's a lake, and it surged quickly down that lake to Olympia, Washington. Anyway, the upshot of all this is where the ice was during the Ice Age. This is a general picture. It was over a lot of mountain areas of the western U.S., so I don't have it accurately drawn. The furthest south was the San Francisco Mountains of northern Arizona. The tops were glaciated. And it covered most of the northern United States, practically all Canada, and just the mountains of Alaska. Why did it miss the lowlands? Now, that's a major mystery of glaciology, the study of ice and glaciers. They don't really know. And they try to run their models to try to figure that out, and I'll revisit that. I actually realized, I was told that there's no talk after mine, so I can go on and on and on. So I decided I'll add the bonus features for you. And I will revisit this during the bonus features that I usually don't talk about if I don't have a lot of time. In Europe and Asia, this is the general location of the ice. And this is from our children's book, Life in the Great Ice Age, I might add, that my wife and I did. Since then, they have discovered that the ocean north of Norway, the Barents Sea, was glaciated. That was always a question, but they're able to look at the bottom features, and they've seen all kinds of glacial features on the bottom of the Barents Sea. So the ice actually extended out in the Barents Sea. Again, this is just a schematic. A lot more mountain ranges were glaciated than show on this. The mountains of Central Asia were glaciated. And notice, in Siberia. Just the mountains were glaciated, but the lowlands were not glaciated. Another question, why were the lowlands of Siberia and Alaska not glaciated? And you know, that's where the woolly mammoth fossils are found in the permafrost by the millions, which just blows their mind of what are these hairy elephants doing up there in Siberia? Well, I'll get to that when in the bonus features. Okay, there was an ice age. Can mainstream scientists really explain the ice age? So the way they talk, sometimes they think, oh, get a little cooling in, it's easy, presto, the ice age occurs. Well, first of all, we have to know what are the requirements for an ice age. Well, winters usually are cold enough for ice age, so that's usually not a problem. In fact, it'd be better if winters were warmer, which they would be after the flood, because of all the warm water that would warm the mid and high latitudes, mainly in the winter, but not the summer. So you need cooler summers. Also, you need much greater snowfall, because summers, if you can get cooler summers, you end up drying out the climate, because the cooler the air, the less moisture it can hold. So that's a problem, and that's why there's over 60 theories of the ice age, 60 secular theories. There's only one area of science that has more theories than the origin of the ice age, and that is the extinction of the dinosaurs. There's more than 100 theories out on that. I should say they're hypotheses, not theories. See, from Kevin's lecture, you learned that a hypothesis is essentially an educated guess. A theory is a well-substantiated hypothesis. So these are in the hypothesis stage. In fact, I consider evolution a hypothesis, not a theory, and certainly not a fact. Anyway, you can't get a climate change just for a season or a year. It's got to persist year by year, so the snow and ice builds up into an ice sheet or a glacier. So that's a pretty tall order. So how much cooling are we talking about? Well, a man did a computer study over Canada, and he cooled off summer temperatures by increments of 2 degrees centigrade, which is 3 degrees Fahrenheit. So he cooled it off, and he ran his model. Cooled it off 2 degrees centigrade, then 4 degrees, 6 degrees, 8, 10, and 12. And when he cooled it off 12 degrees centigrade, what he was trying to do is find out where the 1 inch of the snow remained through the summer, so he can start the ice age. And by the way, he helped himself. He had assumptions that would help the snow and ice to remain. But still, when he cooled it off at 12 degrees centigrade, which is about 20 degrees Fahrenheit, there was his 1 inch line just in northeast Canada. But the ice occurred south of the Great Lakes, so we need a lot more cooling for the northern United States. How much more? Well, I used a city called Minneapolis. It would probably work for Kalispell and for Libby, from cities from the edge of the ice. So the average temperature in Minneapolis in the summer is 70 degrees Fahrenheit. That includes the high and the low. So to cool the summers off so that the snow remains, you have to drop the temperature to at least 32 degrees Fahrenheit. But people that live in cold climates realize that you can get a big snowfall and the temperature might be 10 degrees Fahrenheit and the sun comes out and it starts melting. It's solar radiation, which is the prime mechanism to cause melting. So how much cooler below 32 do you need? I went to an article in the journal Quaternary Research. Quaternary is jargon for the Ice Age period. So they said at the lowlands of Antarctica, in their spring, when the temperature warms up to 14 degrees Fahrenheit, they get net melting at 14 degrees Fahrenheit. Well, you'd have to drop Minneapolis temperature down to 14 degrees Fahrenheit, that means. I'll be more conservative and said just say 20 degrees. So that implies a summer temperature drop of more than 50 degrees Fahrenheit. Where are they going to get that climate change for that kind of a temperature drop? That's the problem. That's why they have over 60 theories. And that's why when you read experts on the Ice Age, not your ordinary professor that teaches about the Ice Age, like J.K. Charlesworth in the book of the Quaternary Era, it was a 1,700-page book just on the Ice Age. I found it fascinating. It put most people asleep. Anyway, Pleistocene is another jargon word for the Ice Age, Tom. But J.K. Charlesworth talked about the cause of the Ice Age, and he said, Pleistocene phenomenon have produced an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. And that included the astronomical theory of the Ice Age that they believe wholeheartedly today. But that was 1957, and we know so much more now. This is modern times, right? Not really. Let's go to a more recent quote. This is U.S. News and World Report, publishing on the 18 top mysteries of science. The 18 top mysteries of science, the whole issue from 1997. And anyway, has anyone picked up on what some of those mysteries are already? Like that first one there? Why should males exist? Well, why is that a mystery? Kevin kind of hinted at this in his last talk, and that in evolution there should be one sex that reproduces asexually. They can't figure out why there's a male and a female. And they write books and articles on this great mystery every year. But that's where the biblical worldview has it hands down on them, because it simply says that God created us male and female. And this is only a problem because they believe in evolution. But some of these challenges, these mysteries are legitimate. And one of them is what causes ice ages. What causes ice ages? In fact, they believe in multiple ice ages, so that's why it's plural there. I only believe in one ice age. Actually, it's two. I'll get to that. Anyway, this woman, Tracy Watson, said in this, secular science has great difficulty explaining an ice age. We've been chewing on this problem for 30 or 40 years. Actually, it's 130 or 140 years. It's a killer. It's embarrassing. They can't explain it. And here's a more recent quote from David Alt, former and late professor of geology at the University of Montana in Missoula, in his book, Glacial Lake Missoula and its Humongous Floods. Yeah, they went from one Lake Missoula flood to 40 Lake Missoula floods to 90 Lake Missoula floods. Why? Well, I'll tell you that tomorrow evening. And he says, although theories abound, no one really knows what causes ice ages. And the latest one I got is Nature, the most widely read journal in the world, in 2008 said, perhaps the longest standing puzzle in neuroscience is what caused the northern hemisphere ice sheets to come and go. They don't know. They don't know. But can we explain it? Can we explain the ice age? First of all, we have to fit the ice age into the biblical worldview. Where does it fit? Is it pre-flood, post-flood? What? Okay. Well, we determined that. I've already hinted that a lot of these glacial features are on top of flood rocks, moraines, scratched bedrock. So it's pretty obvious that the ice age occurred after the flood. So perhaps it was the flood that created the climate conditions for an ice age afterwards until we transition to the present climate. It's in a transitional climate. Indeed, that is the case. How? Well, we have to have cooler summers. Well, the ice age, the flood was a gigantic volcanic meteorite event. So after the flood, you'd have all these particles trapped in the stratosphere. They're called aerosols. They're very fine particles, and they'll cause cooler summers over the land because they reflect some of the sunlight back to space. And it only affects the land and only in the summer. There's reasons the winters would be warmer because of all the warm water. Also, where's the moisture come from? It's come from the warm ocean water. See, the flood mixed up volcanic material. The volcanism would heat the water up. The pre-flood oceans would already be pretty warm to start with because it was a warm climate before the flood. This can be shown from geology and fossils in the Bible. It forms one chapter in one of my books out there. You can see let's get some ideas of what the pre-flood environment was like. So you had a warm pre-flood ocean, all this volcanism, meteorite impacts. You're going to end up with pretty warm water after the flood. And when you talk about sea surface temperatures, the main effect will be much warmer sea surface temperatures at mid and high latitudes compared to today. What does this mean? Well, you can evaporate a lot more moisture into the air at warmer sea surface temperatures. How much? Well, it's known if all variables remain the same, like the wind speed, relative humidity, things like this, that you can evaporate 7 times as much water into the atmosphere with a sea surface temperature of 86 degrees Fahrenheit than you can at 32 degrees Fahrenheit. 7 times. And the main evaporation is going to be at mid and high latitudes, caught up in storms and dumped on the nearby land for a rapid ice age. Huge monster storms, much more snow. So there's where your moisture comes from, and it will persist. How will it persist? Well, it persists because the mechanism causing all this evaporation is the warm ocean. So as the warm ocean cools with time, the ice age will slow down and reach a maximum and then start melting. So you can time it, and it'll persist for hundreds of years because the warm ocean is the key to timing the ice age. So here's, now these particles slowly fall out of the atmosphere, depending on how high they ended up, or started, I should say. But as there was a lot of replenishment of aerosols and dust in the atmosphere, we have 700 stratovolcanoes on the earth, and these are practically all post-flood, and like Mount Rainier and Mount Baker, Mount St. Helens, Mount Hood, so forth. And so these would have erupted mainly during the Ice Age, replenishing the particles in the stratosphere to keep the cooling going on the continent. And that cooling works by reflecting some of the sunlight back to space, as I said. Now the aerosols, believe it or not, the particular type of aerosol ends up being sulfuric acid. That's because you have sulfur dioxide that's emitted by the volcanoes, and they combine with water and oxygen and form sulfuric acid. So during the Ice Age, you're going to have acid rain. That acid rain will weather a lot of rocks. And that's why sometimes when they try to date the ice by the weathering rind on a rock, they think, oh, it goes very slow, and this was tens of thousands of years ago. But acid rain will weather the rock really quick. So in this model, we can answer a lot of challenges. And Charlesworth verifies that there's signs of Ice Age volcanicity and earth movements are visible in all parts of the earth. Lots of evidence for post-flood volcanoes going off, replenishing the particles that cool the summers. No, so here's how it works, a little schematic. Lots of evaporation from warm oceans at mid and high latitudes. You could probably take a swim in the Arctic Ocean right after the flood. Maybe it was about 70, 80 degrees Fahrenheit. And reflecting a lot of sunlight back to space from the tops of the clouds also. Lots of snow on the cold land. So, that's in a nutshell the Ice Age model. But we want to know how fast it was. We want to know, do we need 100,000 years for it? Or is it much quicker than that? Well, how rapid was it? This is my evidence that was very rapid. This is it, Jenkins. Indisputable proof that the Ice Age caught these people completely off guard. Yes. Anyway, the way I approached this, I added up all the heating terms for the ocean and all the cooling terms. And you get a change in temperature, change in time. So I estimated that the initial ocean temperature was about 30 degrees centigrade, and when the ocean temperature cooled to an average of 10 degrees centigrade, the ice age hit a maximum. But 10 degrees centigrade is still a lot warmer than the ocean today. The average temperature of the ocean today is 4 degrees centigrade. And so just that much of a cooling, 20 degrees centigrade. So how long would it take the ocean to do this? So in adding up all the heating and warming terms, there's no way to be accurate. So the way I approach this, I used outrageous examples to get minimums and maximums, because I wanted to bracket the middle. Are we talking about a long period or a short period? So here's the range I got. Short is 174 years to reach glacial maximum, or 1765. The best estimate is about 500 years. 500 years to reach glacial maximum. But how thick was the ice? Well, I did the same thing. There is a number of variables, and I used maximums and minimums. So I got ranges for the variables. For the northern hemisphere, you can see the range. The best estimate was an average of 2,330 feet. For Antarctica, about 4,000 feet. Now, this average in Montana, east of the Divide, we know that the glacier came down to about Cut Bank and south of Havre, and it was very thin because the Sweetgrass Hills stuck up above the ice. The western end of the Cypress Hills stuck up 300 feet above the ice, so the ice was very shallow. And we expect that because the moisture comes from the warm ocean, and Montana east of the Divide is pretty far from the warm ocean where the moisture source is. But you go to northeast United States, southeast Canada, which would be close to the warm Atlantic Ocean, and several storm tracks, you'd have heavy snow. So it was probably something like 4,000 or 5,000 feet thick in that area. So 2,330 feet is the average that I got for glacial maximum. And then you got to melt the ice. Well, there's an equation you can use for the melting of snow and ice cover. And you use the variables of heating and cooling. And once you get up to 32 degrees, further heating causes melt. And the main variable to cause that range was what's called the albedo, the reflectivity of the snow. Reflectivity of snow changes rapidly with time. And so I use maximum and minimums for the edge of the ice sheet called the periphery, which would include the northern United States, maybe southern Canada. You can melt the periphery in about 70 years if it averages 2,300 feet, which it probably didn't. Time to melt the interior is about 200 years, so the maximum time for the ice age turned out to be 700 years, not 100,000 years. So here's a graph of it all, of how I did it. And this is, I must add, this is a rough estimate. Some people wanted me to use a computer model for this, and I keep telling them there's too many unknown variables to run a computer model, so you have to wing it by basic meteorology. And that's what I've done. And so here's the time frame and the temperature, average temperature of the ocean on the left. And here is a schematic of the average temperature with time. Time is on the bottom, and ignore that green line. I might get my artist to take that out. Anyway, the red line is the average summer temperature over the globe. It starts cool. The volcanic aerosols cool the climate, but with time you have less volcanism, and so you're going to gradually warm up the temperatures. But winters are going to start very warm compared to today. And why? It's because of the warm ocean is going to heat up the temperature, and it's going to be mainly in winter that you have the effect. Also, you have a lot more storms in winter that when you condense the water evaporated, you give off latent heat, as it's called. That'll heat up the atmosphere. And it mainly affects the winters. So you're going to have little seasonal contrast at the beginning of the Ice Age. This is a profound difference here. But with time, Winters are going to become colder because you have the oceans are going to cool off. More snow and ice is be on land, so you're going to have a cooling trend. This is a very dynamic climate that it starts off quite mild most areas. And by the way, it's good enough to cause snow and ice, because instead of 40 below zero in Canada, it might be just 10 below. But other places that had no ice would be a lot warmer in the winter. But because of all the snow and ice and the cooler and more sea ice, actually by the time you get to the end of the ice age, winters are even colder than today, dropping below the average winter temperature as the ice was melting. And when it finally melting, you came up to today's temperature. This curve in the blue is a very important result. And this is generally a result of, this is just basic meteorology. This is very dynamic. Mild winters to very, very cold. And it's profound, not only profound effects, it explains a number of other mysteries associated with the Ice Age. Precipitation, you can imagine, with a lot more evaporation, is going to be heavy. Heavy precipitation, not only over the ice sheets, but also where it's not glaciated. I did a rough calculations for the southwest United States, which is semi-arid. And based on the warm ocean, I got roughly precipitation grade about 4 times today. And this is significant because I'm writing a book on the origin of caves today. And it's interesting, the caves in the Guadalupe Mountains of New Mexico, like Carlsbad Caverns, they're hardly not forming today. It's too dry because caves formed by the carbon dioxide formed in the soil. And with little or no soil and cold winters, they're not forming those features, those speleothems today. Very rare. But during the Ice Age, they can form rapidly. Stay tuned. I'll be finishing the book maybe about a year. I'm almost done. Anyway, was there more than one Ice Age? Well, I have a confession to make. I believe there were 2 Ice Ages. There was one before the flood, and it was in the vicinity of the Garden of Eden. This is the Earth's first Ice Age. You figure it out, Adam. Oh no, Eve, why am you acting so cold towards me? Did I do something wrong? Okay, what this is about, this is Dan Letha, formerly of Answers in Genesis, who got this for me. And what this is saying is that when we were first created and sin hadn't entered the earth, man's communication was perfect, man and women. But because of sin, it doesn't work quite that well anymore. And to be very general, women have sensitivity issues because they're different than men, as Kevin said, and men have clueless issues. And I'm one of the clueless males, just ask my wife. Anyway, let's move on. Anyway, let's get serious. Anyway, actually, in most areas where the ice occurred, it only shows one ice age. They get their multiple ice ages from the mud on the bottom of the ocean. Anyway, when they've analyzed these areas, they've actually backed off from the amount earlier. Earlier, they said that southern Alberta up to Edmonton, great place for glaciation, I might add. They used to say 4 ice ages, maybe 5 or 3 in certain areas. But anyway, these researchers, I think there's 6 of them from the University of Alberta in Edmonton, said this in the journal called Geology. They said glacial reconstructions commonly what? Assume a multiplied glaciation hypothesis in all areas that contained a till cover. Till is jargon for geological debris left over after glaciation. So they assume multiple glaciation. So how does that work? Well, they're analyzing someplace maybe near the edge of the ice sheet, and they see some glacial till. Oh, that's an ice age. Oh, but they see a layer of sand in there. Well, that's an interglacial. And then another till layer. Oh, that's obviously 2 ice ages. But it's simplistic thinking because we know that one ice can surge, or slowly move forward, back up, and move forward again. It moves a lot. And you can form a lot of this mix-up and chaos of these features that they interpret as multiple tills. And it's because they assume it. Big factor, they assume it. Will there be a future ice age? Why should this be the case? Well, because we're still in the glacial interglacial cycle. It hasn't changed. Interglacials last about 10,000 years, and the last ice age melted 10,000 years, so we're due soon. In fact, some of you are old enough to remember in the 1970s where they came out that the next ice age is coming, because we actually had global cooling between 1945 and 1975. Well, carbon dioxide was going up really fast after World War II. We had global cooling for 30 years. I have 3 books from the 1970s saying such things as, the next ice age is due, can we survive it? And really scary things. Now they just erase all that, say, oh, global warming, can we survive it? I mean, there's so much hype and propaganda and all that stuff. Anyway, and Daniel Grossman said in the New York Times, if the past is any indication, the Earth is at the end of another such warm period. We're at the end of the interglacial called the Holocene, poised to descend into a new ice age. Now, we believe everything we read in the newspapers, do we not? I have come to believe almost nothing I read in the newspapers. In fact, I was involved in a hunting accident in the Rocky Mountains. I was not the one injured, but I stayed up over the whole night so that Lewis and Clark Search and Rescue could come out and haul my friend out. He was in the wrong area, first of all, and he slipped down a 20-foot waterfall in Elk Creek and had a compound fracture. So it was just a miracle we even found him, because he was not where he's supposed to be. And so we were there all night keeping him warm, and then search and rescue, which I really admire, hauled him up out of this canyon. It was a steep embankment, and then helicoptered him to the hospital in Great Falls. And then the paper reported it the next day. You know, you'd think they get the details correct. They didn't get one single detail correct. Anyway, the rainbow is a promise that there'll never be another ice age, so you can relax. I thought I saw a few people sweating this, because this place was glaciated during the ice age. But the rainbow is a promise there'll never be another flood. And the flood caused the ice age. Therefore, there'll never be another ice age. And that gets back to my title, where the Bible explains the ice age. Well, I have a few minutes for the bonus sections, which I just added because I was told that there's no talk after this, so I'm not under a time restraint. Do you want to see the bonus sections? Yeah, because the ice age can explain a lot of other mysteries. What are they? Deserts that were once wet. Disharmonious associations. I'm going to go through some of these. End ice age mass extinctions. Why the woolly mammoths are in Siberia. Why the lowlands of Siberia unglaciated. And I'm not going to get into 6, 7, and 8. I'm going to save 8 for tomorrow evening. I'm still working on caves, and I just finished a book on a layman's version of ice cores in January of this year. Anyway, we get back to this diagram, and it's because of this climate change that we can explain the other mysteries. For instance, lakes in the dry areas like the southwest United States. We had during the Ice Age, we had these huge lakes in a lot of, it's in the Great Basin, which is enclosed, but there's a lot of smaller basins within the Great Basins, and they had lakes during the Ice Age. Some of them were very large. Death Valley had a lake 600 feet deep. Around Great Salt Lake, which has an average depth of 12 feet, there was a lake 10 times the size of Great Salt Lake called Lake Bonneville, and it was about 800 feet deep. We see the evidence of shorelines all along in the mountains showing of this. Even, southeast Oregon, a very dry area, had lakes. So that's a schematic of that. By the way, this is a global phenomenon. In Israel, the Dead Sea area, it was up to about 1,000 feet higher than it today. So it was a global thing. Anyway, here's some of the shorelines. This is north of Salt Lake. You see several shorelines. The highest one is the Bonneville shoreline, where when it got up to that level, it overtopped a pass on the border with Idaho and caused the Bonneville flood through the Snake River of southern Idaho. And then it dropped about 300 feet and steadied there for a while until the water evaporated, called the Provo shoreline. So these are shorelines, and they're very large and distinct, all around where this lake used to exist. And here, we know it occurred in the Ice Age. Oh, the initial filling of the lakes was probably during the flood runoff that put water in these enclosed basins to start with. So we don't have to fill them up first. They were already filled. But we know that they rose because of the Bonneville flood rising and overtopping, causing the Bonneville flood. And we know it was during the Ice Age. Here is Ice Age Lake Mono near Bishop, California. Here's a shoreline that's carved in an end moraine coming out of the eastern Sierra Nevadas. So we know it occurred during the Ice Age. And here are some shorelines in southeast Oregon. And the Sahara Desert, believe it or not, was well watered during the Ice Age and even for a while after the Ice Age. How do we know that? Well, we have tens of thousands of pictographs, man's pictographs throughout the Sahara Desert. And we have fossils of hippos and other aquatic organisms. And indicating this all didn't happen not too long ago, in about 1900, they found a live crocodile in one of the high playa lakes in the western Sahara Desert. A live Nile crocodile. That is fantastic. Anyway, I'm going to quote from this, James Weller, The Great Sahara. The Sahara is a veritable art gallery of prehistoric painting. The evidence is enough to show that the Sahara is one of the well-populated areas of the prehistoric world. Yet there is man's work in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals, like hippos, enormous herds of cattle, hunters armed with bows and boomerangs, and even domestic scenes of women and children in the circular huts in which they lived. Well watered, and we can explain this by our post-flood Ice Age model with a lot more precipitation. Okay, disharmonious associations. What in the world is that? That's an association of plants and animals from warm climates together with cold climates found in the same Ice Age debris. Disharmonious associations. And by the way, this was not the exception. This was the rule during the Ice Age. And this really stresses secular scientists because when they run their Ice Age model, the Ice Age is cold, winter and summer. So I don't even think the cold climate animals can survive what they come from their models, what they result in their models. But the warm climate animals, what were the warm climate animals doing with the most outrageous example is hippopotamus fossils found in northwest Europe. 100 locations in England, you find hippo fossils in Ice Age debris. Hippos are a tropical animal. And first of all, I'm getting ahead of myself. This quote says that, well, it was the rule. Late Pleistocene communities were characteristic by the coexistence of species that today are allopatric, translated, not climatically associated, and presumably ecologically incompatible. Disharmonious associations have been documented for late Pleistocene, that is Ice Age floras, that's your plants, terrestrial invertebrates, lower invertebrates, birds, and mammals. It's the rule. totally against uniformitarianism. And here's the most outrageous example. In the valley of the Thames, southern England, that's the river that goes through London. For instance, woolly mammoth, woolly rhinoceros, muskox, reindeer, those are cold climate animals, hippopotamus, and cave lion had all been found by 1855 in stratigraphic contexts that seem to indicate contemporaneity. In other words, they're found in the same sediment. And by the way, we can explain those hippos there because you have the warm Atlantic Ocean. Onshore flow is going to keep northwest Europe and England mild, warm, and wet during the Ice Age. So hippos leaving the mountains of Ararat and spreading out that way, as well as going south, would find a congenial environment clear up into England. But as the temperatures cooled off, they found themselves trapped. And cold climate animals came in there and they all died together. So we can explain this, but they are totally perplexed. Disharmonious associations. In Ice Age mass extinctions, it has been discovered that at the end of just the last Ice Age of the 50, 100 species of large animals in North America, that is 70%, went extinct. Woolly mammoth, Columbian mammoth, cave bear, not cave bears, they're in Europe, saber-toothed tigers, ground sloths, and other animals. In Europe and Asia, about 40% went extinct. In Australia, 90%. South America, 80%. And Africa, only 20%. Wow, how did that happen? And it's only at the end of their last Ice Age. And some say man killed them off. Others say, no, the climate killed them off. Some say, oh, both. And here's from a book. And the guy, the editor said, after many decades of debate, the North American end Pleistocene megafaunal mass extinction remains a lightning rod of controversy. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. But we can explain it because there's only one Ice Age. And the Ice Age was so dynamic, the winters were so cold at the end, that caused, and with that you had droughts and other features that would cause the animals that weren't used to cold to go extinct. We can explain this. And also, why weren't you have all these extinction at the end of the 49 other Ice Ages? Because nothing happened during those, supposedly. It's only after the last. Well, could it be that there's only one Ice Age? Should be a big hint that there's only one Ice Age. Woolly mammoths in Siberia. There's a woolly mammoth. Many of us have seen that. That's his distribution during the Ice Age, the red area. They're not found in glacial debris in the central and northern parts of the North American ice sheet or the Scandinavian, which indicates that they're associated with the Ice Age. And they don't know why they would live in Siberia by the millions. And the experts up there that work on them say there's millions. And they also don't know why they went extinct there or anywhere. Woolly mammoths were down in Montana. Here's a book by Larry Agenbrog and Lisa Nelson. Why did the mammoths disappear from the earth? This question remains one of the great unsolved mysteries of the past. We don't know, but this model can solve that. I'm going to skip all this. And the unglaciated lowlands of Siberia. And here's a schematic of that. The reddish areas were glaciated. Those are just the mountains. And the yellow areas were unglaciated. And it's in the unglaciated areas where you find the woolly mammoth fossils. They're not found in glacial ice. They're found in permafrost, which has a lot of ice in it. And that's where the woolly mammoths were found. And why are the lowlands not glaciated? Well, they've tried to solve this by their climate models. Here's one. It's rather old. It's from the Journal of Climate. They have to try hard to get glaciation because it's difficult. So they cool off. They decrease what's called the solar constant by 6%. So you had a lot less sunshine. So they finally got glaciation. As I said in that quote, we now have glaciation, like they're celebrating, but mainly outside the area where it existed during the last ice age. In other words, they glaciated the lowlands of Alaska and Siberia and the highlands. Also the Tibetan Plateau, which was not glaciated. Just the mountains of Tibet were glaciated. Okay, in summary, the Ice Age was a real event not that long ago. It is a major mystery for evolutionary Earth science. Noah's flood caused a transitional climate for an ice age. The Ice Age lasted only 700 years. We don't need 100,000 years for an ice age, and there was only one ice age. So ultimately, only the Bible explains the Ice Age because of the flood. And there will be no future ice age. Concluding thought, creationists have a viable mechanism for the last major event in Earth history, while evolutionary scientists are far from a solution. Then, why should we believe them for all those older ideas and events? Thousands of historical hypotheses. The origin of this, the demise of the dinosaurs, the demise of the trilobites. There's a whole bunch of thousands of these events, and yet they can't explain the last one. We should be skeptical of what they say. And by the way, these are not facts of science. These are interpretations of fossils. The Ice Age is an example of what can be done with hundreds of other science challenges to the Bible. Yeah, since I keep up with 50 Earth Science journals, there's hundreds of challenges. We have answers to many of them, and we have the big picture. But we're working on a lot of details in their science. And I might add that some people are embarrassed by the young Earth time scale based on Genesis 5 and 11. But I found that time is not a side issue in all this, but a young Earth time scale sometimes is the key to solving major mysteries that have lasted over 150 years. How so? Well, they know that volcanoes cool the climate. We've observed that in the last 200 years. Krakatoa, when that went off, Tambora in 1815, caused the Earth out of summer in the northern hemisphere in 1816. So we know that large volcanoes cool. Now, Mount St. Helens was too small to do any cooling at all. So, and they know that you had all this volcanism, but each volcano going off is separated by hundreds, maybe 1,000 years. So the cooling trend only lasts a short time, a year to 3 years, and it's insignificant. But what if you can push all those volcanoes that went off, that we know went off during the Ice Age, into a couple hundred years? Then you have a powerful mechanism to keep the cooling going by the short time scale. And I have a personal reason for being skeptical of a lot of this stuff about millions of years. Thank you, Dan Letha, for this one. I have done this. Being a weather forecaster, I've ruined probably thousands of outdoor activities. Tell me again why I should trust scientists' ability to be accurate about life on Earth millions of years ago. Yep. Okay. Another concluding thought. The Ice Age is based on the flood. Therefore, the flood, one of the most despised events by the culture, is a real event of the past. Therefore, it is easy to believe the whole Bible, which tells us how to live here on earth and how to go to heaven. And the best verse as far as that last part, if you confess with your mouth that Jesus is Lord and believe in your heart that God raised him from the dead, you will be saved. These are commitment adjectives and verbs. You need to be committed to Jesus. You will be saved. Anyway, a few advertisements. Since I've been in this for 50 years, and this is my main topic, the layman-friendly book is still Frozen in Time, The Woolly Mammoth, The Ice Age, and actually the Biblical Key to Its Secrets has been retitled. And we have DVDs, and now these are not ordinary DVDs. It is done by Kyle Justice, where we go out in the field and show you the actual features over about 100 minutes. The Great Ice Age. And I have a new Ice Age book out that just came out in December. How Noah's flood caused a single ice age. Now I first published a book on this in 1990. It's out of print. It's the only book that's out of print that I've written. And this kind of summarizes that book, but all these other topics that I've been working on for 50 years are in here. Now, this is a rather detailed book, so it's not too difficult. You just have to have patience to read all the details, that's all. But if you really like to dig into things about the Ice Age, you can get that. And this just came out in January, The Frozen Paradox, Ice Cores versus Deep Time. Ice cores, they claim you can count annual layers down to 110,000 years in the Greenland ice sheet. And the ice on Antarctica is over 800,000 years. You know, that had put a real trip on a lot of Christians, which is why I went into ice cores. So I've written an in-depth book about 20-some years ago, and this is a layman-friendly version of that book, answering a lot of those challenges. And how do we explain how the ice got on Greenland and Antarctica? You know, it's just not challenging them, but I'm providing answers for you. And of course, my wife and I did this quite a while ago, Life in the Great Ice Age. This might have been one of the first children's books. I think it published in 1993 in the creation movement. It's a fun story from the eyes of a 12-year-old boy living in a cave in Germany, south of the ice sheet, having adventures, they hunted woolly mammoths, and they had to roust out a cave bear. Also, you had another people group called Neanderthals that they had a great summer together. So it's an adventure book teaching about the Ice Age. And we have a sequel to it, Uncovering the Mysterious Woolly Mammoths, which focuses in on the woolly mammoths that went extinct and why at the end of the Ice Age. Oh, and if the millions of years are bothering you, in fact, polls have shown that of any challenge we have, especially the young people, it's the millions of years that are thrown at us, called deep time. Anyway, I've written a layman-friendly book, The Deep Time Deception, examining the case for millions of years, that will help you understand. And it has a lot of references if you want to dig deep. So this is my last advertisement, and I thank you for being with me this afternoon and staying pretty much wide awake.